to the previous page. And if we need to look at another graph, that's fine. If not, I would like to look at functions. I don't have the graph. Easy to read, so to speak, unless I have to approximate, la la la. But here I no longer have the graphs. Here I'm asked, here's the function, find the domain. Question, do we need to look at other graphs, or we look at the expressions? How would I write, for example, the domain of 21? Domain of 21 cannot be written with brackets or parentheses. No such thing. We have to use the interval notation. The set builder notation, not the interval notation. So, for example, in 21, on page 32, the domain will be written like this, with braces. -3, comma, -1, comma, 1, comma, 3, comma, 5, comma, -3, -1, +1, +3, +5. That's it. I have to use braces and use like a roster. It's also called, not roster, but it's called set builder notation. So I list them. So like a list. Now the range, the same way. I cannot connect them. The points don't exist between the points. So -2, comma, 0, comma, 2, comma, 3, comma, 4, comma. That's all I can write. These are the only y values. 0, what was it? 2, 3, and 4. And that's it. Okay, any questions on this? Okay, let's choose problems 33 through 51 and determine their domain. Every function is different. They're all require different things. Anyone would like to pick, or I will? Okay, I will. I'll start with 39. 39 has a function that is x minus 2 over x minus 12. 6x minus 12. Okay. What could be a problem? So this is a function, so rational functions. I like to call them not friendly. Not friendly. I have to worry about them, in other words. They may give me problems. What problems? What could be the issue with a rational function?
If the denominator is 0, you can't divide by 0.
6x minus 12 can never be 0. Perfect, thank you. I move 12 and divide by 6. So x cannot be 2. And you can say, but you can simplify this function. Yes, I can. But it doesn't matter. The restriction stays. And I cannot state restrictions before I have to state the restrictions before I simplify. I cannot simplify before I state the restrictions. No, no, no. So now, if I have x minus 2 and then 6 and x minus 2, I can simplify it. And the answer and the simplified form is 1 over 6. It doesn't matter. The domain of this function is anything but 2. How do I write anything but 2? -infinity 2 union to infinity. This is the domain. I have to state the domain before I simplify. So division by 0 we know is undefined. The denominator cannot be 0. If the denominator is 0, the function does not exist. Any questions? And this is the way we write anything but 2. Good. So this is a rational function. Any questions? So please remember, rational functions cannot have 0 in the denominator. Here's another function that I consider not friendly, like, for example, 45. 45 is not a friendly function. 45 is the square root of 4 plus 5x. What could go wrong with a radical function? And before you say anything, there are two different types of radicals. Radicals with an even index and radicals with an odd index. So what's the difference between the two? One is friendly and the other one is not. Very friendly. Not at all. Why the even index is not friendly and the odd index is? Zeta, you're doing something very interesting, I'm sure, but what do you think this is? Ashton, I like your flag.
For this one, I'm not sure.
Okay. Anybody would like to join and help? Okay, so remember, when we take a square root from a negative number, the answer is an imaginary number. So the quantity under the square root has to be positive or 0. That's why I say it's not friendly, because I cannot put in anything I want. But in a radical with an odd index, anything goes. Positive, 0, and negative, everything goes. No question, no problem, no issues. Friendly, not friendly. Similar to the rational function. The rational function has a different issue. The rational function cannot have a 0 in the denominator. But the radical, if the radical has an even index, then we have to state exactly what you see here, meaning the quantity under the square root has to be greater than or equal to 0. And we have to solve this inequality. We move 4 to the other side. We divide by 5. So that's exactly how we find the domain, from negative 4/5 to infinity. There is another function that is not friendly, but we have to wait till chapter 2 to discuss it. I will tell you what it is. It's the logarithmic function. These three functions are not friendly. Again, which ones? Rational, in case the denominator can be 0. Radical, when the index is even. When it's odd, no issues whatsoever. Domain all real numbers. And the last one is the logarithmic function. These three functions we have to be very careful about. Okay, any questions for me? Let's review the lines, etc., and the two formulas. So the slope, so we have, again, this is just algebra, nothing, as I said, we only had one exposure so far to calculus. So R.4 lines. I'm just going to list the formulas for the lines. First of all, the slope formula, which we already used several times, y2 minus y1 over x2 minus x1, which is also the average rate of change. Oh, I'm sorry, I'm sharing and I didn't. I wanted you to see this. Y equals mx plus b, which is the slope y-intercept formula. And we have y minus y1 equals the slope times x minus x1, which is point slope formula. Just remember, this is exactly this. They're identical. So this is the slope definition. Once we have 2 points, we can always determine the slope of the line passing through those 2 points. But this is the same thing, in which we replace a y2 and x2 by y and x. So these are identical. If you remove the suffix on y and x and you cross multiply, you get this. Okay, so also we know that 2 lines, if they are parallel, they have the same slope. If they are parallel. If they are perpendicular, so they form 90 degrees, etc., etc., m1 equals the negative multiplicative inverse of the other. I don't like this formula. Just cross multiply. m1 times m2 equals -1. You remember it the way you like, it doesn't matter. But this is so much easier to remember. Here, if they are parallel, the slopes are the same. If they are perpendicular, the product equals -1. Instead of saying one slope is the negative multiplicative inverse of the other. No, the product is -1. You remember it the way you like. It doesn't matter, it's the same thing. Okay, so let's practice a little bit. So here they're asking us to find the slope and the y-intercept. And here they're asking us to find the equation of the line given 2 points or given the slope of a point, etc., etc. What would you like to choose? What do you think we should work on?
You like 15?
Okay, perfect. Let's look at 15. So 15 is asking us to find the slope and the y-intercept. So before I copy 15, just remember, as long as the formula or this we are using the slope y-intercept, as long as we solve for y, the number in front of x will always be the slope, and this will always be the y-intercept. But this is basically 0, comma b. Because the y-intercept has x equals 0, as we already know from our previous examples somewhere some time ago. Okay, so the y-intercept has to have x equals 0. Good. So now let's copy 15 and let's take a look. What was 15 all about? 3x minus 3y plus 6 equals 0. All I need to do is solve for y. Once I solve for y, I will be able to determine the slope and the y-intercept. Can anyone tell us how to solve for y? First step, what will be the first step towards solving for y? Anyone, please?
Would you have to isolate it?
Yes. What will be the first step? Correct. Very good.
So subtract 3x and subtract 6. To
Very
the other
good.
side.
Excellent.
Solve
And
both sides. I know.
yes, And always put that in the correct order, meaning y is on the left, x should be, the term with x should be first, and the term with no variables should be last. And of course now, in order to solve for y, I have one more step to go. What is it?
Divide by -3.
Indeed, we divide by -3. This by -3 is y, this by -3 is x, this by -3 is +2. The number in front of x is the slope, and this one is always 0, 2, which is 0, b. And the slope would be, what number do we have in front of x?
1.
Indeed. Good, perfect. Any questions from me here before we look at the next problem? Okay, perfect. So now let's select something else. We're given 2 points. We're asked to find the equation of the line. I think we should work on this set because this is the same. Y-intercept is this and the slope is that. So it's up to you. Let's choose one more. Anyone would like to pick one? Or you can make, yes?
25.
Okay, very good. Let's look at 25. In 25, we have the y-intercept is 0, -6, and the slope is 1/2. This is a very simple situation because I only have to do this and replace this by 1/2. I'm sorry, and replace this by 1/2 and this by -6. So I have, I'm given the slope, which is 1/2. I'm given the y-intercept, which is 0, -6, which means b is -6. So y equals 1/2 x minus 6. Let's choose an example in which we are given 2 points to determine the equation of the line.
Can we do 35?
Absolutely. Let's look at 35. 35 is -5, 13, and no, I'm sorry, you said 35, I'm not looking at 36. So -8, -3, and -3, -12. Perfect. In order to determine the equation of the line passing through these points, we must find what first? We need to find
Slope.
the slope. Very good. Yes. y2 minus y1 over x2 minus x1. Just write it as x1, y1, and x2, y2. Label them so you don't make a mistake. And carefully enter them. -12 minus -3 is -12 plus 3, which is -9. -3 plus 8 is 5. So the slope is -9/5. Notice that these, none of them is 0, a number. None. Because I do not have 0, a number. I am forced to use this equation, the point slope formula, in which it doesn't matter which point I use. So, y minus y1 equals the slope times x minus x1, where the slope was determined as -9/5. choose any point you want. Let's say we choose -8 and -3. Notice what I just did. Of course, it's up to you if you want to use this method. I prefer writing everything underneath so that I don't have to use nested parentheses. Because I have minus minus, I know this is y plus 3. The -9/5 will stay, and minus minus will change into plus. And now I will distribute. I have to solve for y. So I distribute -9/5, -9/5 x, and minus 72/5. And then I have to bring a -3 to the other side. When we move terms from one side to the other, all we need to do is change the sign. That's the easiest thing to do. Instead of writing minus, minus, and so on and so forth, it's up to you. If your method works, stick to it. Okay, so now finally I have y equals -9/5 x minus, so this is 72 minus 15. 72 and 15 is 87. So minus 87 over 5. What is this? Well, this is the equation of the line passing through the given points. Any questions? Any questions? Anyone would like to say anything? I'd like to finish tonight with something called profit and loss analysis. Okay. So when we start a business, we have costs. We hope to have revenue in the sense that we're basically triggering profit. Costs have two components, fixed and variable. Revenue is just one component, one term. Profit is always revenue minus total cost. Okay, minus total costs. So let's look at a situation, very simple, and discuss profit and loss. I know I only have 4 minutes. I'm giving an eye 3 minutes. I'm giving an eye on the clock. So Jamal decides to mow lawns to earn money. Good. The initial cost of his electric lawnmower is $250. This is fixed. This does not depend on the number of units he manufactures, so to speak. Electricity and maintenance costs are $4 per lawn. $4 depend on the number of lawns he's going to address. But the $250 is fixed. So this is his $250. This is the variable, 4 per lawn, 4x. So in this problem, the cost function of x will be 4x plus 250. This is for the lawnmower. It doesn't matter how many he's going to work on. And this is the cost per lawn. So this is the formula for the total cost function. The next step, he determines that the total profit function is given by, so they are giving us the profit function as 16x minus 250. Good, so we have the profit. Find a function for the total revenue. No problem. No problem whatsoever, because I know that the revenue, profit equals revenue plus cost. I'm going to move the cost to the other side to find the revenue. So R of X revenue equals profit P of X minus cost of X. I have P of X and I have cost of X. So, I'm sorry, revenue is plus. I'm moving it from negative to positive. So then the revenue equals profit 16x minus 250 plus 4x plus 250. These two are gone. So then the revenue equals 20x. So we determine the function that is giving him the revenue. Good. How many lawns must Jamal mow before? So how much does the Jamal charge for per lawn, first of all? How much does he charge for each lawn? How much?
20.
That's it. So he's charging 20 per unit. And final question. How many does he have to mow before he begins making a profit? So this is something called break-even point. The break-even point is when the profit is 0 or when the revenue equals the cost. Either you say profit is 0 or revenue equals cost. So the profit is 0, 16x minus 250 equals 0. I move to 50 and divide by 16. And I divide, and that's 250 divided by 16. So 15.6. Well, he cannot mow 15.6 lawns, right? So I will say 16. So he needs to mow 16 or more in order to start having profit.